All right, let's jump right in. Every single day, whether you realize it or not, you're fighting a war. Seriously, it's this constant battle against an invisible enemy, lurking on your countertops, on your skin, even inside critical medical gear. And no, this isn't some sci-fi movie. This is the very real science of microbial control. So today, we're going to crack open the strategist's playbook.
But here's the big question, the one that really matters. Are you actually winning this war? Or are the things you're doing just making the enemy tougher? Because in this battle, believe it or not, using the wrong weapon can be even worse than using no weapon at all.
So first things first, before we can even dream of picking our weapons, we've got to understand the battlefield itself. We have to define the rules of engagement. What do these words we throw around actually mean?
And this right here is probably the most crucial distinction of all. On one side, you have sterilization. I want you to think of this as total annihilation. It's a process that wipes out everything, and I mean everything, even the toughest microbial survivors out there, called spores. Then you've got disinfection. Now, this is more like a surgical strike. It's about eliminating the harmful germs, the pathogens, from things that aren't alive, like your kitchen counter. So one is a total scorched earth policy, the other is a precision mission.
And why does this all matter so much? Because the stakes are incredibly high. All of these tactics, sterilizing, disinfecting, they're all designed to prevent one thing: sepsis. This is what happens when the enemy breaches our defenses and starts multiplying in our blood and our tissues. This is the absolute worst-case scenario.
Okay, time for an intelligence briefing. Any good strategist will tell you you have to know your enemy to win. And let me tell you, not all microbes are created equal. Some are pretty easy to take down, but others are like microscopic supervillains. And here they are, the microbial most wanted list, ranked from the absolute toughest to the easiest to kill. Right at the very top, you've got prions, these misfolded proteins that are just insanely resistant. Right below them, bacterial endospores. These are the armored tanks of the microbial world. Then we work our way down through mycobacteria with their waxy coats, gram-negative bacteria with their extra layer of armor, and way down at the bottom of the list, we finally get to the enveloped viruses, like the flu. They're actually the most fragile of the bunch, the easiest ones to take out.
So, how do we fight back? Well, our entire arsenal, everything we've got, is designed to hit them right where it hurts. We can go after their cell wall, basically their outer armor. We can attack the cell membrane, making it leaky and unstable. We can target their proteins and enzymes, essentially scrambling their internal machinery so nothing works. Or we can go for the kill shot. We can attack their very blueprint, their DNA and RNA, to stop them from ever making copies of themselves. These are their 4 biggest vulnerabilities.
All right, now for the fun stuff, the weapons. First up are the physical weapons. I want you to think of these as the shock and awe tactics of our war. These are the brute force methods that just completely overwhelm the enemy.
Just take a look at this. Good old-fashioned boiling water at 100 degrees Celsius. It's a solid disinfectant. Pasteurization, which we use for food, uses a bit less heat for a short burst to do the same thing. But now, look at the autoclave. By adding pressure, 15 pounds per square inch, we can crank up the temperature of steam to a blistering 121 degrees Celsius. And at that temperature, for just 15 minutes, we get complete sterilization. That pressure, it's an absolute game changer.
And this just shows you how massive that difference is. To get that same level of sterilization with just dry heat, like in an oven, you'd need to bake something at 170 degrees Celsius for 2 full hours. But with moist heat in an autoclave, just 121 degrees for 15 minutes, it's just no contest. That water is incredibly efficient at transferring that deadly heat.
We can also bring in the heavy artillery, radiation. On one hand, you have ionizing radiation, like X-rays. This stuff has serious penetrating power. It goes right through objects, which makes it perfect for sterilizing things like medical plastics that would melt with heat. On the other hand, you have non-ionizing radiation, like UV light. Now, this is a surface-level weapon. It can't go through things, but it's fantastic for disinfecting the air or the surfaces in a room.
All right, let's move on to our next set of tools. If heat and light are the shock and awe, then our chemical agents, well, these are our special ops. These are the precise, targeted weapons we use for very specific missions. So first up, we've got the halogens. Think common household bleach. These guys are powerful oxidizers that work by just wrecking the essential proteins that microbes need to live. Then you've got alcohols, like the ethanol in your hand sanitizer. They work by dissolving the fatty outer membranes of microbes, pretty much making them fall apart from the outside in.
And the list just keeps going. We have surfactants. These are the key ingredients in soap. And they're brilliant. They have a head that loves water and a tail that hates it, which lets them physically wedge themselves into a microbe's membrane and just tear it apart. We even use things like heavy metals. Silver is a classic example, which are great at shutting down key proteins and stopping microbes dead in their tracks.
So we know the battlefield, we know the enemy, and we've seen the weapons. Now let's pull back the curtain on a few secrets from the lab that you can actually put into practice. This is where theory gets real. So here's a classic trivia question that trips a lot of people up. It just feels wrong, doesn't it? I mean, why on earth would a diluted solution be more powerful than the pure stuff?
And the answer is just fascinating. It turns out 100% alcohol is, well, it's just too aggressive. It hits the microbe and instantly hardens all the proteins on the outside, basically creating this little protective shield. And that shield stops the alcohol from getting inside to do the real killing. But when you add a little water to make it 70%, that water acts as a brake. It slows down that hardening process just enough to let the alcohol sneak past the gates, get deep inside the cell, and then destroy it from within. So that water, it's not a weakness, it's the secret weapon.
And here's another super practical tip. The concentration of your weapon matters a lot. For just general household cleaning, a 1:99 bleach solution is perfect. But if you're dealing with something much more serious, like vomit, you've got to ramp it up to a 1:49 ratio. And for something really high risk, like a blood spill, you need a powerful 1:4 solution. Knowing the right ratio for the right job is absolutely critical.
And really, that's what this all boils down to. Winning this invisible war isn't about just grabbing the biggest, strongest weapon you can find. It's about being a strategist. It's about knowing your enemy, understanding your objective, and choosing the right tool to get the job done safely and effectively.
And that leads us to one final lingering thought. This battle, it's never really over. The enemy is smart. It's constantly adapting, evolving, and building up resistance to even our best weapons. So the question we have to leave on is, what's next? What will the future of this endless war actually look like?